Hello everyone, welcome to this video. My name is Amir Ahuri. I'm a Google Earth Engine expert. In this tutorial, I'm going to show you how to extract information about the soil in the Google Earth Engine platform. It's very simple and easy to use technique that helping you to get various information about the soil type and soil characteristic in your study area. Let's go to the code editor environment in the Earth Engine platform. So, in the first step, you need to identify the region of the interest. But I will prefer to talk about that in the next step. And at the first time, I'm gonna show you how to find appropriate soil data through the search places and dataset. As you know, through the search places and dataset, you will be able to browse into data catalog. Into data catalog, browse by tags or available tags, helping you to find your data according to the target of interest. For example, here my target in this study is about the soil, and inside the box filter dataset tag, I'm typing soil. As you can see, various datasets available regarding to the soil tags: soil moisture, soil water, soil, organic soil. As you can see, 33 datasets available for the soil. Go to the soil tags, and as you can see, various products existing here and various products available here, helping us to get information about the soil. If you scroll down, here there are some global products about the soil. For example, soil clay content, soil taxonomy, soil organic carbon, soil pH in H2O, and sand content, and on it goes. In this tutorial, I'm going to show you how to use these products in the Earth Engine efficiently without any complexity. It's very simple and easy to use programming, and if you don't have information about the programming steps, don't worry, because working in the Earth Engine is very simple, and you can write your script as simple as this possible. So, for example, in the first step, I'm going to show you how to visualize and call soil pH data in H2O. Go to the data. If you click on each data, you can see that the information is related to a period of time. Is available here, the dataset provider, and Earth Engine snippet. The main ID helping us to call this data into the code editor environment. And the spatial resolution is 250 meters in the global scale. But remember that this product is a single image, not an image collection. It doesn't mean we can show for example, soil pH for daily, monthly, or yearly. There is only one image that calculated soil pH according to the information available since 1950 to 2018. More information needed, description here is available, and you can use it to get more information about the product you are working with. And also in the citation, you can cite this data in your research paper or project you are working. So, in this step, I'm going to show you how to call this product in the Earth Engine platform, and then how to visualize it, and how to get statistical information, and how to get export. These are main steps that everybody looking in working with Google Earth Engine platform. So, back to the code editor environment, and now for the first step, without any attention to the study area and the region of the interest, I'm gonna visualize this data for the whole of the world to see which areas covered by this product. Make a new variable, for example, soil pH or only pH. Trying to set the simple name for the variables, because several variables we are making in the programming, and would be better to use simple name that's easily memorable. So pH equals to, so go to the data description here. you can see that this data calling with earthengine.image the snippet ID. So copy and paste it into your code and then through the map.add layer, you will be able to visualize the result. So pH, no need to clip it based on the region of the interest because I want to see this product in the global scale. And then leave the visualization part empty for now, or you can copy and paste the visualization characteristic through the visualization variable available in the code editor environment. For example, I copy and paste the visualization parameters into the code, and as you can see, the main band is the first that's showing in the data description that's showing this is including soil pH data for the surface of the earth, not deeper actually spaces. So now as you can see the bands minimum, maximum and the palette. So instead of visualization, we can use the visualization variable here to show the pH value according to the parameters including in the visualization dictionary. So the layer name could be, for example, soil pH, and then use the false at the end. Run the code, and after a few moments in the layers, you will see a result, soil pH. If you check it on, you can see that this product covering a global scale. Those of regions and the color palette showing like that, and regions with the green and blue color showing higher pH, and the regions with green and yellow colors shows the actually lower soil pH in H2O. So, and then through the inspector available here, you can get the exact value for each point you are working. For example, when I select a point, you can see that the value of soil pH from the surface into the deeper parts. As you can see, the value varies into the deeper parts. Actually, when you go through the soil deeper, you can see that the amount of pH in the H2O increases. So, and then in the next step, maybe you want asking about how to export this product for only one region of the interest. It is also very simple technique. Thanks to Google Earth Engine data catalog, hydroshed products show hydroshed products that showing and dividing Earth's surface according to the border of basins. You can select your target basin to extract soil data for that. So through the search places and data set, just type hydroshed. Hydroshed basins available in various scales. For example, scale number 5 is one of the most popular scales in working with basins layer. But it depends on you which scale you are using for the basin. So, and now in the next step, for example, I'm gonna select a region. For example, in the Europe, just randomly, I'm selecting the region, for example, in the Germany, and then I'm gonna call the hydroshed layer for this region. First of all, through the map.add layer table, you can see the you can see that how the word is splitted according to the basin's border in level number 5. And the region I'm selecting, as you can see, the selected region is related to one basin in Germany, and I want to select or clip the basing layer according to the point of interest. It's a very simple and easy to use technique. Make a new variable such as region of interest, helping us to select the target basing. The table from the table dot filter bound only select the basing that I have selected by geometry, and then through the map.add layer I can show the only region of interest. Map.add layer, region of interest, and through the map.center object I can have focus on the region of interest more accurately. As you can see, when the code runs, the map focuses on the region of interest, and now only we have the target basing here. So in the next step, you can see that through the dot clip, you can only show the soil characteristic for the region you selected by the ROI. So, and here soil pH data is available now for only the selected region, and you can increase the contrast here if you need. For example, I'm increasing the contrast. The blue region showing the higher pH and the red region showing the lower pH value. So if you want to download the pH data for the region of interest, it's very simple and easy technique. Just use export.image to drive. So make a new parenthesis. Inside the parenthesis, various arguments we can use. The first and important argument is the image. Which image you want to export, you want to get export. The pH image that is clipped based on the region of interest. The description referring to the name of output file for the GeoTIFF file. For example, this is the pH data for the region of interest with any name, but I don't know its exact name for this region because I randomly selected this area. So the next important argument is a scale, referring to the pixel size and defined based on the spatial resolution of the data. And the data spatial resolution is 250 meter, and a scale should be 250 meter too. So the next important argument is the region. The region of the interest or ROI used for the region here. So, and the next is CRS, the coordinate system. We can get the coordinate system information from the data ph.getInfo, so helping us to get information from the server side to the client side in the Earth engine, and then .crs helping us to get coordinate system from pH data that its information already gathered from the server side and transferred into the client side. So, and another important thing is about the folder you want to keep your data in. For example, the folder, my target folder in the Google Drive is the test, and I want to save this data in the folder named as a test. So now save your data or code and then run it. When you run the code, task is highlighted. We have a layer pH and you can save it into the Google Drive. And after the process of saving is done, the tab's color turns to the blue like this. And then you can go to the Google Drive and pick it up and open it up into the desktop software. As you can see, this is very easy to use technique. But one thing that missed in my code is the band of interest. Now pH containing the all bands available into the image. If I print here, if I printing the pH, just a moment, yes. Here you can see the image including 6 bands, the pH values in different depths. If you want to select only one of these, now the data is saving with all the bands. But if you want to select only one of them, for example the first band, you need to use .select or add it into the image. .select which band? The target band. That is the first one. Yes. That is the first band that is related to the study of area. So as you can see, the process of saving is over, is done. And now if I click on opening Drive, directly go to the Google Drive test folder, and then you can pick it up from there. So it's very simple and easy to use technique. So in the next step, I'm gonna show you how we can get histogram for this region, because sometimes it is important to know how the pH value ranges in our study area. That is very important things. So to do this, I'm gonna make a new function here, print user interface chart image.histogram. Image.histogram helping us to plot the histogram for the region of interest. The histogram function helping us to visualize the frequency of different values of target band or target image in the region of interest. So the target image is pH and the target band is band number 0, or the first band that uses for pH estimation for the surface of soil surface actually. So the region is ROI and the spatial resolution is 250. Now a new chart is generating that's showing the range of pH value for the region of interest from 41 to 75, for example, and the frequency of different values plotted very well here. So, and you can save this plot through the icon available here, direct it to a new page or new tab, and through the download CSV, you can download the Excel file format to do the further process in the Python or Excel or any other software you are working. So now everything is ready, and also I showed you how to call the data, how to visualize it, and also how to plot the histogram, and also how to get export and how to select the target band. That is very, very important things. So now I'm gonna show you how to make a function that you can apply all these steps for all the soil products available here. So as you can see here, we have various products from same data provider that helping us to get various information about the soils. And now I want to show you how to avoid repeating these steps for all of these products. Now we want to make a new product here, or we want to make a new code or new function inside the code that helping us to repeat this process for all the bands we need in the for all the soil data available in the Google Earth Engine platform. So make a new step. Now I'm gonna actually turn all the existing code to a dictionary or the data dictionary or the text or description through the control slash, because the control slash converting the code into a simple text, and also because I'm not gonna use this codes for the next step. and also whenever I want a back, it's very simple to select them and use the Control/ or in Macintosh by Command/ I can transfer it back to the earlier situation. So now I'm gonna make a function that helping us to call this information or gather this information for all the soil products available in the Earth Engine. So in the first step, it is important to set a region of the interest easily. So as I mentioned earlier, to set the region of the interest, we are using the ROI and filter bounds. That should be out of the function structure, and it is necessary for the next step processing also. So we have a variable that selects the target basing through the geometry we defined, and then plot it and center it on the map through the add layer and center objects. So in the next step, make a new function. For example, the function name is soil, and this function has multiple arguments. So the function needs one argument about the collection snippet or collection ID. The first argument is ID because for each data we need to define an ID. So after the ID, the target band or the band of interest is very important. So another argument here is band. And also for the output layer name, we need also again a name for the visualization, for getting export or something like that. And also the name that referring to the characteristic of the data. For example, for the pH, we can set the name as pH, and for example, sand, the name could be sand, or on it goes. So in the body structure, you can write or type all the process or steps we have done before. So for example, the first step is about the calling the target data. I'm copy and paste this part into the actually the body structure of my code. So, but this time, instead of inserting a particular ID, just enter ID inside the Earth Engine.image, because later I will show you how to use different IDs in this platform. When one ID related to the pH imported, the image will be called the pH data. But if I use another ID for sand data, the image calling the sand image. So accordingly, the name of the variable should be a general. So the name could be a collection, but this is not a collection actually. This is one single image. So because we are calling this data using Earth Engine.image. So after calling the image, the target band is very important. Through the dot select, you can select the target bands here. My target band could be anything that we enter as band in a string format here. So in the first line, I'm calling the target ID image, the target image through the ID, and select the target band through the band arguments. So that's the first step in the function. The next step is about the visualization. Because of the different plots for different variables and different actually image or soil characteristic, I prefer to don't use the visualization characteristic or same visualization for all soil properties. Because when you get export from the Earth Engine, you couldn't save the visualization parameter with the output image. It doesn't matter necessarily you have the visualization parameter in your function. So the next important thing is about the map.add layer. So here, using the map.add layer, for example, I'm gonna visualize the target image that is clipped based on the region of interest, and then I'm leaving empty the visualization parameter. So here the layer name could be should be a string. Actually the layer name should be equals to the name argument, and use the false at the end to avoid automatic visualization, because highly reduces the speed of processing when you are working in the Google Earth Engine platform. So the next important thing is, for example, get a histogram for the region of interest. So just copy and paste the histogram parameters here and select and remove the double slash here. So now we have a print including the histogram for the target image. The target image replace the ph that select replaced by the image, ROI is ROI, and spatial resolution is also the same. And also, more importantly, if you want to get some statistical information, it is also possible in the Earth Engine. For example, in addition to the histogram, you can get the minimum and exact minimum, exact maximum, and the average value for the whole of basins you selected. It is also possible in the Earth Engine, making a new variable, so statistic equals to from the input image dot reduce region, helping us to use to get a statistical information using reducers and according to the region of the interest. So, for example, the reducer, I'm gonna get minimum, maximum, and average. Earth Engine dot reducer dot mean. Now I'm getting the average value, but I want to have average, minimum, and maximum. To add a new reducer, use the combine here. Dot combine, helping to combine or mix more than one reducers. Earth Engine, so here make a new dictionary here inside the parentheses. Reducer number 2 equals to Earth Engine reducer dot mean and max. Mean and max. Yes, like this. Mean and max reducer helping us to get the minimum and maximum value for the region of the interest. In the next step, we need to define the region of the interest. Another argument is geometry. Geometry equals to the ROI, because we want to get average, minimum, and maximum for the region of interest or geometry that is selected. And the next thing is about the scale. Should be equals to 250 according to the spatial resolution. Here we have a statistical information. But to show and visualize the statistical information, in the right panel, just print stats. And before stats, you can add a new text. For example, a statistical information for plus name. The name of variable or the name of the properties we want to get a statistical information for can be added to the text through the plus sign. So after then, if you want to get export automatically, again copy and paste the export file here and then convert it from simple text to the code. So with a little change, the image you want to get export is the image variable that is clipped based on the region of interest, and the description, the output name equals to the name argument and leave the other, and also the pH here replaced with the img, and the target folder could be test or anything you want. So now I'm making a little space. I'm separating different codes here through the enter and to see the different parts easily. But remember that when you're making a function in the Earth Engine, it is important to return a final result. The final result should be returned by the function. For example, the final result for me is the target image. That's it, no more. And the rest of the image returning by the function export will be go to the task, and a statistical information visualized in the right panel, and also map.add layer, and then final map visualized in the map frame I have. So this is a raw function that I can use this function for all of the soil data available in the Google Earth Engine platform. So now in the next step, I'm gonna show you how to use this function for all the soil data in the Earth Engine. You can collapse the function by the icon available here. It's very helpful technique that uses to reduce the amount of the text or amount of the codes that are showing, that helping you to understand better what's the difference between the function structure and the simple variables. So, for example, here I'm gonna use this function for the pH data again. pH equals to the function name and arguments copy and paste it here. So close the parentheses. The input ID for the pH data. Go to the data description. For each data you selected, there is an ID. This is the ID for pH data. Copy and paste it. This is the ID, and the target band. For all the products, you have various bands. You can select one of them. You can choose B60, B30, B10, and also it totally depends on your target. Back to the code, the band selected, and also the name. This product, this variable showing the pH for the region of interest. So just I'm running the code. So some unexpected happened. One extra parenthesis here removed, and then I'm running the code. Image is not defining image, and now I'm running the code. As you can see, this is actually as you can see here we have a plot, but there is a problem about the dictionary and also the reducer I used. Oh yes, here one arguments or shared input should be added. Shared input true, meaning that for the different reducers we have a same input. I'll run the code. Shared input, shared inputs. Demissed here. I'm running the code again. Now problem is solved. You have the histogram for the region of interest. You have the maximum and the minimum value and the average value for the selected region. And also automatically you have a pH data available and also is ready to save in the Google Drive. You can see. And also in the visualization part, you have a pH layer that you can visualize it with a grayscale. And then I'm increasing the visual properties. The brighter region, higher pH, the darker region, lower pH. As you can see, instead of repeating the codes again and again and again, just I'm making a function that is useful for all the products. Now, in one variable, I have pH map with all the characteristics, and now I'm gonna use this code, for example, to get information about the other characteristic of soil in my region of interest. For example, I'm gonna information about the clay content, how much clay content is available in my region of interest. Back to the code, make a new variable about the clay, soil function, inside the parentheses, 3 arguments, ID, band, and name. So here, instead of ID, I copied the ID of clay data, clay content ID comes first, and then the target band. As you can see, various bands available here. I'm gonna have the value for the first band, that is for surface, and then the next one is the name. The name is optional and you can pick any name you want. For example, I'm gonna use clay to show that this data is related to the clay value. So code again is running. For the same region, I will have the clay values, the range of values for the region of interest with minimum, maximum, and average value, and also I have its image ready to export or ready to save in the in the Google Drive. So, and then in the layer settings, the clay layer is also available, and you can visualize it with 90% enhancement techniques and to see the visual characteristic of clay content. Here, the brighter region, higher clay content, and the darker region, lower clay content. You can see it's very, very useful and easy to use techniques in the Google Earth Engine platform. So no matter which kind of soil product you are using, as long as you want to get information from these maps, this function works, and also it's very, very useful. I hope you liked this tutorial, and if you had any problem regarding to this tutorial, first of all, compare your code with mine. The code link available below the video description in a single box in my YouTube channel. And if still problem exists, you can reach me out through the comment and put your comment there. I hope you like it as much as we do. Thank you for your attention.